Okay, hello everyone, and welcome into lesson 2. This time we're going to talk about theoretical probability, okay? So this isn't based on like an actual experiment like lesson 1 was. This is about what could potentially happen, okay? So in this section, we'll answer the question, how do we find the probability of an event without performing an experiment, okay? So we don't actually have to roll a dice 100 times to see what the probability is, okay? This is the probability the probability of an event that is likely that the event will occur, okay? So the number will always be between 0 or 1 or 0% to 100%. Okay, so we either use decimals or we use percentages. Okay, so if we're looking at this number line here, anything that has a 0 probability or 0% chance of happening is impossible. Anything at 1 or 100% will be certain. Okay, if it's 0.5, that's 50%, so there's a 50-50 chance of it happening. Okay, so these are all ticked off by 1. So if we go 0.1, a 10% chance that something happens, very unlikely. But if we go up to 0.3, it's just unlikely. So it's a little bit more likely to occur than if it has a 10% chance, but still unlikely. Okay, we go up to 7, sorry, that should be 0.7 or 70%. Is likely to occur, 70%. Or if we have a 0.9 probability or 90% probability, it's very likely to occur. Okay, so all of our final answers will range somewhere between 0 to 1 or 0% to 100%. Okay, so let's look at, say if we were to roll a die. Okay, the probability of rolling a negative number on a regular die would have a probability of 0 because it's impossible to get a negative number. You can only roll 1, 2, 3, 4, 5, or 6. So probability of getting a negative is 0. The probability of rolling a 1, 2, 3, 4, 5, or 6, so one of those 6 numbers, would have a probability of 1 or 100%. Okay, because on a regular die, you have to roll uh, one of those numbers. If you're rolling like a d20, like in Dungeons and Dragons, then that wouldn't be 100% because you have more options. But if you're just rolling a regular 6-sided die, then the probability that you roll a 1 or 2 or 3 or 4 or 5 or 6 has to be 100% because those are the only options. Okay, so for any event A, the probability of A is n of A divided by n of S, okay? So n of A is the number of elements in that set, so like the number of ways that we can have that, and ns is our all possible outcomes, okay? So, or the number of all possible outcomes. So this is what we call our sample space. Okay, our sample space is everything that could possibly occur. So the probability is the number of ways that we can get A to happen divided by the total number of outcomes. So if we're looking at the probability of on a die of getting a 1, 2, 3, 4, 5, or 6, well, there's 6 ways of getting that divided by 6 possible outcomes. So that's why it's 1 or 100%. Okay. The other way we can do it is with a Venn diagram. Okay, so we'll be talking more about Venn diagrams in our next couple lessons as well. It's just a nice way to kind of like visualize everything to make it easier to see the probabilities of specific outcomes. Okay, so S is the rectangle is S. Okay, so this is our whole sample space. So everything in here, or as myself would say, everything that the light touches is our land. Everything inside of the rectangle is our sample space S. Okay, A is a subset of S. Okay, so A is a subset of S. Sometimes the subset can contain the entire set, but most of the time, our S is everything. And what we're looking for is just a small sample, or it could be a large sample, but just a small section of the total. Okay. So let's find the probability of rolling a 6 uh, on a regular die, okay? I'm going to say let A be rolling a 6, okay? So that is my... So you can always start off with a let statement. Makes it nice just to let you know what you're doing, okay? Oh, sorry. We're rolling a factor of 6. Oops. My mistake. So we're rolling a factor of 6 on the die. Okay. And what are the factors of 6? So we can either roll a 1, a 2, a 3, or a 6. Because 1 times 6 is 6, 2 times 3 is 6. So those are all the factors of 6 that you can roll on die. 4 and 5 aren't factors, so we can't roll them. Okay. So we always want to say let statements to say like what we're actually looking for. So the probability of A rolling a factor of 6 would be equal to the number of ways that A can occur divided by our total sample space. Okay, so we have 1, 2, 3. We have 1, 2, 3, 4 ways of rolling a factor of 6. So we'll have 4 divided by 6 possible outcomes when you roll a die. Okay, and that would be equal to 0.6, say 67, or 67%. Okay, on any test or quiz or assignment, I'll tell you what if I want it in the form of a decimal to a certain number of decimal places or as a percentage. Okay, if we wanted to show this as a Venn diagram, what we could do, so this is my total sample space here, right? So within my sample space, I have 1, 2, 3, and 4 because that is my A. And then 5 and 6 are still in my sample space, but I'm going to move them because it kind of looks like 56 there. They're still in my sample space, but they're not within A itself. Okay, so I have 1, 2, 3, and 4 that are in the big rectangle, but also within the circle. 5 and 6 aren't in the circle, but they're in the big rectangle. Okay. Okay, so that's the, so this is showing the elements. If I wanted to do this in red, show the number of elements, I would just write how many of each there are. Okay, so within my circle, I have 1, 2, 3, 4 different numbers. So I have 4 elements in there. And outside the circle, I only have 5 and 6. So I have 2 elements. So I have 4 in my circle, but the total adds up to 6. Okay, so that's kind of how we can start to use Venn diagrams. But we'll talk about that more, a lot in lesson 4, I believe, and then a little bit in the next lesson as well. So find the probability of selecting a face card from a full deck of cards. Okay. And if you need help remembering what deck of cards look like, here it is. We have clubs, spades, hearts, and diamonds. So we have 2 black suits, 2 red suits. They all go from ace, which we count as 1. 1, 2, 3, 4, 5, 7, 8, 9, 10, and then 3 face cards in each suit. Okay. So here I'm going to say, just because we have a new example, I'm going to say let B be the event of selecting a face card. Okay. Yes, I'm still on the call. Okay. So it doesn't matter what the letter is, But sometimes if you have more than one thing going on, it's nice to change the letter to let you know which probability you're looking at and which event you're looking at for each letter. Okay, so how many face cards do I have? Well, I have 3 in each suit. So you can either go 3 times 4 or just count them up here. But we have 12 face cards. And how many total cards and S do I have? Well, I have 52 cards in the suit, or 52 cards in the deck. So if I'm looking for the probability of B, that's N of B divided by NS. So I'd have 12 divided by 52, which is the same as 3 over 13 if you go down to lowest terms, or about 0.23 or 23%. Okay, so these are the 3 ways you can have your final answer. Have as a fraction, as a decimal, or as a percentage. Again, I'll specify which one I want you to answer it as. Okay. Example 3, find the probability of not selecting a face card from a full deck of cards, okay? So there's 2 different ways we can do it. We can either do it directly or indirectly. Okay, so I'm going to say let C be selecting the face card. Oops, I can't spell select. Again, math teacher, not an English teacher. Selecting a face card. Okay. Or sorry, not selecting, we're doing not selecting. Let B be not selecting a face card. Okay. So how many different ways can I get C to occur? Well, I have 10 cards in each suit that aren't a face card. So I have 40 total numbered cards. And again, I have 52 cards in a full deck. So the probability of selecting C is equal to 40 divided by 52. Okay, which is 10 over 13 in lowest terms, or 0.77, which is equal to 77%. Okay, so that's how we can do it directly, but we can also use our indirect method that we are using with permutations and combinations. That's going to be a little bit different. So what we're going to do is we're going to take our total probability and subtract the probability of the opposite happening. Okay, which our total probability always adds up, always goes to 1, because remember, we know something is guaranteed to happen, our certain probability is 1, okay, or 100%. Find indirect probability, we always do 1, because that's our total probability, minus the opposite occurring, which we call P, the probability of our event prime. Okay. So C prime, actually here, I'm going to change the color. C prime is just the opposite of C. C prime is opposite of C. Okay. So we would have 1 minus, remember, we just found what the opposite is, right? The probability of selecting a face card is 0.23. Okay. So then probability of not selecting a face card, it's double negative there, be minus 0.23, which again is 0.77 or 77%. Okay. If you wanted to do 100% minus 23%, you can do that as well. You still get 77%. Okay, so if you like working with percentages better, you can. I like to work with the decimals first because sometimes I ask you the very final answer in decimals. Okay, so just like with permutations and combinations, we can use an indirect method. And when we do an indirect method, we always do 1 minus whatever it is. Okay, so the probability of A prime occurring, so we call this A prime. A prime is 1 minus the probability of A. Okay, oh, I have it here. A prime is the complement of A, and it contains all the elements in S that are not in A. So if we're looking at our total sample space S, everything in the circle is A. Let's use colors. So everything here is in the green. If I say that blue is my sample space, A prime would be everything that's in the rectangle, but not in the circle. Okay, so it looks something like this. Okay, so if we have our subset of A prime is everything that's the opposite of A, but still in our sample space. And then A plus, oh, I used it right, plus A prime equals S. So if you take A and add it to A prime, you get S. We'll talk about that more in our next lesson. And then the probability of A plus the probability of A prime equals 1, because everything is guaranteed to happen in that space. Okay, so A plus A prime equals our sample space, and the probability of A plus the probability of A prime equals 1, because there's 100% of either getting A or not getting A. So if you are looking to draw a face card, there's a 100% chance that either you draw the face card or you don't draw the face card. Okay, so that'll be it for this lesson. There are some practice questions, but just note that the textbook doesn't count. That just sent me text. The textbook doesn't count Ace as a numbered card. So if you're doing your questions and you get a slightly different answer, that's why. Okay, but that'll be it for this lesson, and I'll see you all in lesson number 3. Have a great day.